for the introduction. My name is Rebecca Chaucy. I'm a geospatial researcher with the Yale Humanitarian Research Lab. Today, I will be going over our concept of a workflow for a South Sudan early warning analysis to detect potential human security incidents. So before I go into detail about our South Sudan concept, I want to give a little bit of a background of where this concept came from. So between March to June 2024, Yale HRL documented the intentional razing of 41 farming communities near El-Fasher, Sudan, allegedly perpetrated by the Rapid Support Forces. What we found was that the razed communities were burned in the same geographic area, as you can see on the map here, and within close time frame to each other. What we also found is many communities were actually burned like sequentially to each other, where the closer that they were to other burned communities, the more likely that they were to be potentially burned. And what we found is that the methods that we applied in El-Fasher, Sudan could potentially be applied to South Sudan, specifically focusing on Jonglei State, South Sudan, where clashes between the South Sudan People's Defense Forces and the Sudan People's Liberation Army in opposition have disproportionately impacted civilians and their communities. So because of this, we built a semi-automated system that will be able to identify arson attacks and potential human security incidents, which can then provide information such as forced movements, as well as risks to nearby communities, and provide potential imminent warning of displacement events, while also monitoring for substantial changes to agricultural activity and other food security related indicators such as market activity. So what does this early warning concept actually look like? So we will be using openly available satellite-derived fire detections from NASA's Fire Information Resource Management System, or FIRMS, and satellite imagery where we can then detect potential arson-related human security incidents. And our goal is to provide information on the location event, nearby communities that may possibly be at risk due to their proximity, as well as assess for damage to the community and critical infrastructure that may also be damaged. Following this analysis, we get a human security incident confirmation, and we will then be able to monitor the communities months following the attacks to assess for what we call the domino effect of human security incidents or arson attacks. So what this actually looks like is we have the community of Walgok in Jonglei State, South Sudan. And what we're looking at on the screen here in blue are the Google Open Building Footprints. And so these are all the building footprints in the area for the community of Walgok and other nearby communities. In red, we have the NASA FIRMS detections, which are pretty much thermal anomalies or potential active fires. And there are approximately 12 NASA FIRMS detections in this area on the 6th and 7th of February. So what we're proposing is we are able to identify detections that are occurring within a predetermined distance of these building footprints. So the closer to buildings, the more likely that we're assessing that they're potentially related to an arson-related human security incident. And so in this case, we are assessing all FIRMS detections within 100 meters of a building footprint. And right now, we see there are three FIRMS detections that are highlighted in the brighter blue, and those are within 100 meters of the building footprints. And so this tells us that these specific areas, we should probably look into more detail with satellite imagery to confirm if a human security incident possibly took place at this location. So in the days following the identification of the thermal detections or FIRMS detections on the 6th and 7th of February, we were able to use a pre and post change detection composite using Sentinel-2 imagery to identify changes in the near infrared band reflectance. And so what's important about a near infrared band reflectance is that thermal scarring in burned area actually reflect very low in the near infrared. So we can use that to identify potential areas of thermal scarring or burning. And so what we're seeing in the left-hand image, which is more of that reddish yellow image that we're looking at, the yellowish and brown color means that there are little to no changes in the near infrared reflectance, while the reddish color actually shows that there's a significant decrease in the near infrared reflectance. So we assess that to be likely thermal scarring. Now, if we look below in the chart below, you can see that there are observed changes in the near-infrared reflectance across time. But what we can see whenever we compare the red diamond, which is the pre-image, to the post-image, which is the green diamond, that there is a significant decrease in the near-infrared. And the significant decrease was actually over 46%, which corroborates that this is likely not consistent with historical trends and is likely newly observed thermal scarring. We were also able to use very high resolution satellite imagery collected on the 7th of February, where we were able to actually identify damage to tucles, and we were actually able to identify a phenomena called selection, where there are spacing between burned tucles, and that is an indicator of intentionality whenever it comes to arson attacks. So in the days following this analysis, which we were able to confirm that there was likely an arson attack human security incident on the 15th of February in satellite imagery. We were then able to see in open source reporting collected on the 21st of February that the South Sudan People's Defense Forces were deliberately burning homes and killing civilians in Walgok during this time frame, which between the date that we were able to identify the potential thermal scarring in satellite imagery versus whenever we were able to see the confirmation in open source reporting, that was about a week time frame difference. Not only can we identify arson-related human security incidents, but we're also able to identify building damage. Here is an example of the community of Lincoln in Jonglei State, South Sudan. On the 4th of February, Doctors Without Borders identified that the South Sudan People's Defense Forces destroyed their hospital in Lincoln the day prior in an airstrike. Although we did not get a NASA firms detection on the 3rd of February near the MSF hospital, we were able to get a NASA firms detection on the 9th of February in a nearby area. And we were able to look at pre and post imagery collected on the 31st of January and then the 15th of January, which you can see with the animation at the bottom of your screen, bottom right of your screen. And you can see the changes in reflectance between the two images. And so whenever we're seeing a very dark, smudgy brown black color, that is likely thermal scarring. And so what we're seeing here is that the firm's detection that was collected on the 9th actually gave us a tip-off that there was actually additional damage to critical infrastructure. And what we found whenever we clipped the potential damage to the open building footprints by Google was we confirmed damage to the MSF hospital. We also confirmed damage to the warehouses as well, but we also identified damage to a nearby market. And what was interesting about this is we, again, cooperated with reporting that the South Sudan People's Defense Forces hit the MSF hospital and nearby warehouse with an airstrike on the 3rd of February. But we also identified damage to a nearby market that was not previously reported on until the 21st of February. So again, we were able to identify the damage to the market on the 15th of February, but it did not appear in open source reporting until the 21st of February. So to try to round this out, we think that this workflow is an effective mechanism to detect arson attacks and damage to communities faster, while also providing information on troop movements in nearby communities that may be at risk. This is especially critical whenever we are talking about rural communities that are in non-permissive environments that open source information may have a significant lag between when the event actually occurred versus when we actually see it in open source reporting. In addition to this, we are wanting to, again, identify human security incidents, but monitor the communities over time to assess for any substantial changes to the community's pattern of life, which is a displacement indicator, as well as any substantial changes to food security related indicators, such as market activity as well. And this is really understanding the domino effect that arson attacks and human security incidents have on the community and their other nearby communities that are within proximity to the communities that were damaged. We're also hoping to expand where we're able to conduct this analysis within South Sudan in collaboration with local partners that we're in communication with, as well as expand to other areas of interest as we assess that this method or this workflow has ability to be used in many environments as well that have a similar type of conflict that is happening. And with that, I'm happy to answer any questions. And also, I have my email on the slide if you would like to follow up and chat further. Thank you all so much.